Hello dear Olga users. My name is Knut Even Lundsbakken and I am an Olga product analyst here at SLB. Today I want to talk about some new functionality in Olga 2025.1. Olga 2025.1 is a very fresh release containing a lot of interesting new functions and features. And specifically I want to talk about our new solver. Olga 2025.1 is coming with a new additional solver created for simulating two-phase CO2 simulations in a more accurate and robust way. Note that the solver is created for CO2 usage and is not compatible with water. For regular oil and gas simulations, the standard Olga solver is still the recommended one. So, really short on our new solver. Our new solver is set up in two stages. For each time step, the velocities, the pressure, and the energy are updated. In the second stage, the masses are updated. As the energy and pressure are solved simultaneously, the pressure computation is constrained by the energy equation, which increases the stability of the solver. The new solver is available in Olga 2025.1 and will be offered with a separate license. Let's have a look at the demonstration. So this is the same demonstration as my colleague Alexander Brigado has done in our user group meetings. Our demo case is simulating an operational restart. We have a pipe which is filled with CO2 gas, and then liquid CO2 is replacing the gas. First, I will compare how sensitive the results are to the time step between the two solvers. I will now run the case with the standard solver. Let's look at the holdup in the section. We expect this to be 0 at the start and then increase as the liquid enters the pipe. The holdup in this section looks like this. What we can see is that the holdup looks a bit shaky and increases a bit slow. So experimental data tells us that we should expect a sharp increase in holdup, almost like a piston. So what we see here is not accurate. I have also made a parametric study where I compare the sensitivity of the maximum time step of the simulation. The two cases are then 100 of a second and 1 millisecond. If we now look at the value of the holdup from the parametric study, we can see that the holdup is smoother than before, and with smaller maximum time step, the more piston-like and accurate the holdup will be. So we can say that the results are time step dependent. Okay, so let's now do the same experiment using our new solver. This can be chosen under option and under the key solver. You can then choose Neo, which is the new solver. Let me run the case using the new solver. And now, if we plot the holdup, we can see a much sharper edge on the holdup, which is more accurate and in line with the experimental data. More like the piston that I mentioned. I have also in this case run a parametric study to check whether the case results are time step dependent, which was the case with the standard solver. Let me just find the plots here, just be a bit patient. And there we go. As you can see, there are still small differences, but the new solver is quite less dependent on time step, and you have a much sharper edge in all cases for the new solver. Let's also compare the results with the initial simulation with the standard solver. The result is quite different, as you can see by the plot. The cases are 100% identical. The only difference is that the second one is run with the new solver. I trust this demonstrates the accuracy and robustness of our new solver. Let me just emphasize again that the new solver is better for two-phase CO2 simulations. For single-phase, gas or liquid, it is as good as the standard solver. For three-phase simulations, the standard solver is still the way to go. And with that, I will end this demonstration. I hope that you enjoyed it and that you will check out our new Olga release, Olga 2025.1. And I will catch you in the next one. Thanks.